Okay, so Arya, let's start. Okay, so today we're gonna continue from the program what we did last time, right? So what did we did last time? So we got the ball to move around the
we got the ball to move in the x direction.
yeah. But now we want to make the ball to do more interesting stuff.
Yeah. The
And-
game doesn't have a ball just moving in the x
Yeah,
direction.
we want to do most interesting. So let's do it. So first, let's make the ball a little smaller. Let's make the ball a little smaller. So we're gonna make it 25.
Yeah.
Let's see what happens. So we're gonna make the ball 25. We say way to run it. Yeah, better. Let's make the ball a little faster. So we'll increase the speed
By
by
50 pixels.
Let's say make it 50. Maybe
Yeah.
double it. And no, still not good enough. Maybe make it 100.
100.
Yeah, so let's do a little bit more stuff and we'll try to understand. So we can change the position, right? So one of the thing is that if we make this 0, 0, where the ball will be now?
At the top.
At the top. So the ball is at the top. If I make it 0 and let's say what is the total height? It is around 500. So if I make it 500,
And the ball will be at the bottom. 0.
the ball will be at
Yeah.
the bottom. And if I make the ball
1000.
1000,
Now we are along the other side and we'll just get off the screen.
yeah, we will be off the other side. So maybe in this scenario we want to take it minus and see what happens. Okay,
We'll go the other way.
yeah, it will go the other way. So
Because
yeah, so now we are getting this going the other way. So yeah, nice. And we can be at the top. So we kind of understand it. But let's be at the bottom left side. I mean like that side.
oh,
bottom.
they're right there.
Yeah, the bottom left side. That will be
0.
okay. So that is a bottom left side, and yeah, again,
It went.
and yeah, it is. Yeah, so that's something you need to know. Whether if it's got out of the screen, you will not see anything. So yeah, now let's make the ball move. You know, like maybe like sort of a like little upward direction. So what we can do?
Upward.
So to do that, let's add another thing which is speed in y direction.
Speed x, y.
Let's add it in the y direction. Let's make it 100. And now,
We have to do the same thing for y.
so now we just need to add the same thing in the y direction. So we need to multiply this thing with the,
y.
we need to add it, and we need to left time, and you need to do it y direction.
Y.
Okay, so
Yeah.
now, so if we want to go up, what we need to do? We need to do minus y, right?
Yeah.
So let's
Because-
see what happens now. So we go
Up.
nicely up. Okay, so we go up, we go forever up. Yeah, so a
Because
little more
we're
interesting.
detecting collision.
We are doing little bit more interesting stuff now.
Yeah, but we go.
What if we want to make not lot go up but slightly up? We
Then
want
you
to
might have to change y a bit.
yeah, we want to make a y little bit lesser.
Like
Let's
50?
make it 50. Yeah, now it's going little less up. So now the problem is we need to, this is getting too many variables, right? And we
Yeah.
need to make it little more easier for us to
Understand.
understand. So we are going to learn a concept called vector. Okay. So let's understand the concept of vector, and that will allow us to maybe make things little simpler as we work on other interesting problems. Okay.
Okay.
So what is a vector? So basically, vector is
Vector is
a quantity. Vector is an entity which represents
magnitude and direction.
magnitude and direction. So we're going to talk about that, magnitude and direction. Okay, so we're going to talk about it. So when we were giving the speed in, let's call them like the x vectors, and we were giving the speed in x and y direction. So this was speed in x and the speed in y. So this was a vector.
Yeah.
Okay. Now, to understand this, what we can do is we can make a graph. Okay. We can make a graph. So when we said, let's say this was 100, this was 200, and this could be 300. And similarly upside, 100,
That's 30.
200. So if we
That's
have,
30.
yeah, so this is the x direction and this is the y direction.
Daddy, that's 30.
Yeah, 300. Okay. So this could be one way you can have x and y direction. But when we are playing when we are doing stuff in our pi game, the coordinates are a little different. The x direction is this and y direction is this. So it's going downward positive. Okay,
Yeah.
it's positive downwards. So that is a little bit you need to understand. Remember that is a difference here.
That's why you have to do negative if you
Yeah.
want
So
to
you
go up.
you want to go up, then you have to do negative. Okay. So this is the 3, right? Now when we say we have a vector which says let's say a, and that's how you denote vector, an alphabet with a arrow over top of it, and we write the vector as 100, 200. So this 100 is the x component and this is the y component.
Is that position?
No. So
Initial?
this means that let's say 100x is here and 200 is here. So what does this mean? The vector is in this direction. So this is the direction of the vector. Another thing to note is that a vector does not mean it has to start from 0. So anything which is, let's say another vector starts here and both of them are equal length, right? And they both are going in the same direction. So if this is a vector and this is b vector, because their size or their length is same and their direction is same, so a is equal to b. Okay, in math we'll write 1 equal to, not 2 equal to. So both our vectors are same. Similarly, if you want to draw the vector, the 100, 200 vector for this coordinate plane, it will be little different now. So the x direction is 100 and the y direction is 200. So okay, so this is going to be 100 and 200. So here, right? So as you can see, this vector is in the totally different direction now because the coordinate plane is different. Okay. So that's one thing. So let's do little bit more examples. Okay. So we'll use our craft paper to do it. So let's say you have this, another example. You have this vector like this, and the other vector is like this. Now you can see, like you can see that both the vectors looks, the magnitude or the length of this thing is
same,
and the other's length is also same.
So magnitude is same and direction is different.
Opposite. So it means that a, if this is a and this is b, then a is equal to minus b. Okay. So this is the
minus b means
minus
opposite.
b. Yeah. And what does it mean? Let's say this was 100, a was 100, 200, right? Then b will gonna be minus. So it's gonna be minus 100 and minus 200. So you just have to multiply minus with both of them. Okay, minus 1 with both of them. Okay. Now what else is there? Okay, so let's then talk about another thing. What is the magnitude of a vector? Magnitude of a vector.
No idea.
So magnitude, right? We discussed vector has a magnitude and a direction. Yeah. So the magnitude of the vector is basically, as we said, right? It is the length of this thing. So how do you find the length of this thing? Oh, well, you don't know? Okay. So let's make it little, let's start this from 0 for this time. And let's say we know this length. So this was 1, 2, 3, 4, 5. So let's say this is 5. And this length is 1, 2, 3, 4. Let's say this length is 4. 1, 2, 3, 4.
4 pixels.
So this is going to be a triangle, right?
Yeah.
You can make a triangle. Now you know this side is 5. And you know this side is 4. So how can you
so there, square root.
Yeah, so the thing is that there is a guy called Pythagoras theorem. There is a theorem called
Pythagoras theorem.
Pythagoras theorem. I don't remember the spelling, so I'm going to write something.
So
Pythagoras theorem say if it's a right angle triangle, then
square root
a square plus b square is equal to c square, right?
And then you under root them.
And if you want to find the c will becomes equal to under root of a square plus
b square,
right?
Yes.
So now you just square both of them, which is 5 square plus 4 square, and
That's
you want to
9
find the
square.
under root. Now how do you find under root? Well, we don't know. Let's learn something called, well, we'll write a table of square. 1 square is 1, 2 square is 2, 3 square is 3, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, and 6 square is 36. Okay, so yeah, I mean, let's say how much we get. We get 25 plus 16, right?
Like around.
So it's around like 1 and 41, right? So it's little more than 6, maybe something. Okay, 7 is 49, right? So roughly 6, right? Roughly
Yeah.
6. Again, we don't know. We don't need to know what is the real value.
Decimal.
Computer can find it out, so
Yeah.
we don't worry about it. So roughly 6. Okay. So this is how you find the magnitude of the vector. Okay.
Roughly 6. Oh. Okay.
Yeah. Now what else we want to learn? Okay, now let's go back to our problem of the physics which we are trying to solve. Okay.
Okay.
So as we said, right, vectors basically is an entity which denotes magnitude and direction, right?
Direction, yeah.
And we write vector like this A, B, and then they basically can have like right now we are using 2 dimension where there is only x and y, and this will have x1, y1, and this will have x2, y2, some x2, y2, right? You know, that's like vectors are, right? But when we are solving our problem, we have some specific name for our vectors. So one of the vectors, we'll call it the position vector. Okay, so which is the which we did
We
by
have
we
have
did
a specific position for it.
yeah. So basically an object will have a position,
Position.
and that's what we store in the position
Vector.
and the position vectors always start from 0, 0.
Zero.
So we basically calculate from the 0, 0 what is the distance of the object is.
Okay.
So the object is here.
Here.
So this is the only version where basically we have to
Start at 0.
we start at the 0. Okay, this is the position vector, and then we learn something called as a
displacement vector.
displacement vector. Okay, so what is displacement vector?
It can start every.
So displacement vector means that if the object was here in the first frame, okay,
and then the second.
and then and there was a displacement vector like this, let's say there was a displacement vector like this, then what we can do is, then this is basically telling where the object will move in the next frame. So the object, what will do is that
It will go.
you make this object, it was like this, and
Yeah.
then from the end point you add the other vector.
Yeah.
So the object has moved
Here.
Here.
The next frame.
So object has moved here
Yeah.
now, and this vector becomes the new position.
Position.
So this was the old position,
New
and this becomes the new position. New position. This vector becomes the new position. And similarly, we'll get the next displacement vector to find the position in the next frame and the next frame. So like this. So now, how do we calculate the displacement vector? How do we calculate the displacement vector? So
We basically just added it.
So what we do is that remember what we did is that we just multiplied with our vector, with our velocity vector or the speed, we call the velocity vector with the elapsed time. Time.
Are we gonna add something to that?
Yeah, so to calculate the displacement vector.
Yeah.
So now we have a concept of velocity, and the velocity is also a vector. So the velocity is also a vector, which will tell us,
Yeah, it's a vector.
it's a vector. It will tell us how fast
How fast?
or what is the speed of the object in x and y direction. Okay, so that this will tell us the how the object is moving in x and y direction. So suppose if the velocity is 100, 200, it means that this many pixel per second it is moving. It is moving 100 pixel in the x direction and 200 pixel in the y direction. And also as we learned, right, velocities, so the velocity can have component which is in the negative direction. Okay, so that means it's moving in the negative x direction. So now, since we know all this stuff, let's clean up a code little bit, and we'll use these names. Okay, and then we'll think about how to make the code even better. So instead of writing here, now we are here, instead of writing like this, we can just say velocity, and we'll write
brackets,
comma minus 50. Okay, so this will,
and we don't need these.
okay, and also we don't want to use a list, we want to use a tuple.
Tuple, yeah.
Tuple is a better way of representing vector. Okay, so we're going to use the tuple. Now we have this, and this is our position vector. So this is our position vector. Okay, now
we don't need color index.
Color index, yeah, we don't need, we can remove that now.
We need a color.
And we can remove this also now, we don't need it. Okay, so we got our color velocity and we got position vector. Now as we said, right, every time the object is moving, we need to first calculate the displacement vector. So we'll use the displacement. Oops, I just pressed the caps lock. Displacement vector. The displacement vector is gonna be, you have to multiply time elapsed with our velocity. Now, right now we have to write the the bigger formula. So let's just do that for now, and we'll make it simpler later on. So this is gonna be equal to this.
Yeah, why is it such a big formula? This will. Yeah, we don't need that.
So this is gonna be velocity 0. And this is gonna be velocity
0.
Velocity
not
1.
y
Velocity
anymore.
y is gonna be velocity on the y component. In the
1.
yeah. So this is much better.
And then do we need that position still?
And now we need to add we need to find the new position. So position is gonna be position plus
displacement.
Yeah, and right now we don't have, like, we will have to that we can add our position and vector like this.
Yeah.
But right now we don't know how to do this, right?
Yeah.
So we'll learn that later, how can we just do like this. But for now we need to do more of our work. We need to tell what exactly this means. Okay, and we have to tell it exactly like this. The way what we're going to do is,
we have to add a tuple and make a new tuple.
yeah, we need to make a new we need to create a new tuple, and then we need to basically do comma, and we need to tell this is gonna be the x 0 0 and 0, and this is gonna be 1 and 1. Okay, so we got that, and this got calculated the new position, and then this should work. So let's run it again, and it is still working the same way as we discussed. So a little bit of going back to the maths. What we learned here is that how do you add two vectors? How do you add two vectors? So let's just do. There are two operations we learned. We need to add two vectors. Okay.
And multiply two vectors.
And multiply a vector with a number. Not two vectors. We are just learning how to multiply with a number. So adding two vectors is like when we have a plus b. What does that look like, right?
Equals c.
Yeah, so the vector, like if you have two vectors, which a is equal to 0 3 and then b is equal to 3 minus 1. So what you need to do is you just need to add the component as it is. So 0 plus 3 is 3. 3 plus minus 1 is 2. So you know that, and then that's what we'll get. Another thing to note is that how does it look like in the graph? How does this look like in the graph? So you just basically put all your vector, and the next vector should, the tail of it should touch the next one, and the other one touch, like next this, and then
they all converted.
And you just calculate whatever is the final one, right? And this is the final one. So this is what addition. Now what does multiplying a vector with a scalar or number look like? Okay, so let's say you say 0.5 into a. So what does that look like? So if suppose your a is 1, 2.
You multiply 0.5 with 1.
So 0.5 with 1, how much you get? That you get 0.5.
Five.
And similarly, you multiply 0.5 with 2, how much you'll get? 1.
1.
So you get 0.5 and 1. And what does that look like when you make the graph? So if you have original vector is this, and you multiply with half, the vector will basically go into half length.
Yeah.
And it will still point to the same direction.
But it will shorten.
Yeah, it will shorten.
That's what happens when you multiply with half.
Yeah. Okay. So that's what it means. And if you multiply with 2, it will become twice the length. So that's what two operation we are doing. But what we are doing here was we are multiplying the velocity with the time elapsed. Now that is what it was telling was how much we traveled in particular that amount of time. So that is the most important thing, and we are getting the displacement. That okay, within 20 millisecond we only traveled this small teeny bit. Okay.
Yeah.
But if their displacement, if we have to multiply with 1 second time elapsed, then it will be much more bigger amount of the displacement vector. We want our displacement vector to be small so that we feel that the motion is more smooth. Otherwise it will look like jumping if the displacement vector gets bigger. Okay. So that's what we learned last time. Now if that completes our basic introduction to this one, now we want to do some more interesting movement, right?
Yeah, we discussed
So,
shortening, but
yeah, let's do some more interesting stuff, which is when the ball never goes like this, right? If you throw the ball like this, what will happen? The ball will go like this, then eventually it will fall like this.
it doesn't. This gravity.
Yeah, then there is gravity.
Can't flow in space, not
Yeah,
space.
yeah, you are not in space. You are not on Earth. Now, how can we add gravity?
Oh no, we need a variable called gravity.
Huh?
We need a variable called gravity.
Yeah. So what we learned?
Vector.
Yeah, what we learned till now is that we have something called as velocity. So velocity tells us which direction we are moving
Going in.
moving and per second, right?
1 second, yeah.
Yeah, 1 second, right? And velocity is same. So we are moving in the same direction forever, right?
Yeah.
So velocity is telling this is my constant velocity and this is the direction I will keep moving forever.
But Daddy, the velocity never changes. Like it doesn't.
So yeah, so if you want to move the object in different directions, you need to change the velocity. So how will you change the velocity? So now we need something. Basically now
Change velocity.
in our loop, which will help us change the velocity. We want the velocity to be velocity plus something, right? Velocity plus
one.
something. Yeah, something. So that will change the velocity gradually, and we will have our ball move in different ways, not going just in a straight direction, which is extremely boring.
Yeah. Games have different directions.
Yeah. So we need to learn how to make the velocity do interesting stuff, and then only we will have fun with our games. So now
something can be 5.
So now we learned that last time that velocity is change in position with respect to time. So what we need is we need the same thing. We need something which is change in velocity with respect to time.
Acceleration.
And that is called acceleration. Yeah. So same way we learned that velocity is change in position with respect to time.
Respect.
Because time is the most important factor, right? It's
Yeah.
changing with time.
Yeah.
To time. So now we need similar thing. We'll call it acceleration. And it's right now we'll call it the gravity.
Yeah.
Now we'll learn more interesting way of doing acceleration. Let's call it acceleration only because I don't want to change the variable name for later. Acceleration. And this is basically our gravity only. And acceleration is
0.
We're gonna learn what this is called. Acceleration is basically change in velocity with respect to time. With respect to time.
Because everything changes to time.
And yeah, that is what the velocity is, right? Velocity is changing with time. So that's why the velocity is changing with time, and that term is called acceleration. Otherwise, if you don't have if you have acceleration is 0, it means your velocity is not changing. Okay. So if you start with a 0 acceleration, your velocity is not changing. So let's call it acceleration. Initially we'll have gravity. So what is gravity? Gravity is just accelerating the object downward.
Yeah.
So gravity is just pulling us toward the ground. And what is the downward direction means?
That means the acceleration.
That means accelerating in downward means it's the acceleration in the y direction.
Y direction.
And in this case it's a positive y direction, because our coordinate plane y is increasing downward. So let's start with a small number of 10 in downward direction. And this is gonna be
a vector.
This is gonna be vector again. And x direction, is there anything? Nothing. So x is 0. Now again, this is the same way position was changing with time, right?
Yeah.
And so we multiply our time elapsed with the velocity, right? Now we need our velocity displacement vector.
Velocity plus acceleration.
So the velocity is gonna be velocity plus velocity plus, again we need to kind of multiply with the time elapsed, right? So we need to do the same thing, right? Time elapsed.
Of course.
And we need to multiply with the into our acceleration, right? But again, we cannot do this simply because our velocity, this tuple does not support plus and multiply, right? So we need to kind of do it the hard way, which is we need to do the same thing we did. We need to create a new tuple, and we need to copy this thing. We need to copy this thing again, put the comma, and put it again, and we'll make it 0. Oops.
Oh, come on, why do we have to write this?
Yeah, we will learn how to fix this problem, but for now we need to do this manually. We'll fix this later. Okay, and this is gonna be 1, and this is gonna be 1. Okay, so we got this, and the velocity changed. Now the velocity will keep changing, and let's see how the ball will move when there is gravity, and does it work? Let's see. Okay.
Let's see.
And
I went so low.
Kind of. That's how the ball goes, right?
Yeah, but it'll just fall off.
Yeah, but it's fall off the screen. That's okay. But that's how kind of the ball goes. So yeah, we kind of got it right.
Yeah, but it's not going
it's just
high.
Yeah.
It needs to go high.
You want to get it high?
Yeah.
So maybe you need to increase you need to throw it a little faster. Maybe if you throw it a little faster, then we'll go a little higher, right?
Yeah.
So let's just increase our what?
Why?
Maybe 100, right? Minus 100.
That's not acceptable. Oh wow.
Yeah. Maybe we
Yeah, that went high.
That went high, and it kind of went very high, and it went high enough, and it let's increase our acceleration also a little bit. Maybe make the acceleration double, right? And let's see how it goes now. Now.
Whoa. Now it went kind of like last time.
Yeah. So now it
and
went.
Increase acceleration, the force pulled quicker.
Yeah, exactly. That's what it is, right? So maybe if we make it 100,
it won't even go up.
And now we want to make this as maybe, maybe 300 and maybe minus 300, and let's see how it goes. Okay, now we've increased both the things, right? And let's see how it goes. Okay, it just went
too high.
Too fast. And why don't we just reduce the x direction a little bit? Maybe just make it 100, okay? And let's see what happens. Now we just throw middle up, and this goes like this. So this was much better, right?
Yeah, it went like.
So yeah, so we finally got our ball to move properly.
Yeah, but.
So what is the next thing we want to do?
Like when you press Q and the ball moves.
Huh?
When you press Q.
Well, we can do the key part also, and that will call with the event handling part. Or we can talk about what happens if the ball hit the floor or hit the side, and how should it behave, right?
Yeah,
that could be another thing we can discuss maybe in the
next video.
Next video we'll talk about collisions.
Detecting collision.